Welcome, everyone. Today, we're diving straight into a really fascinating explainer on what is basically the ultimate invisible engine running our digital lives. We are talking about Microsoft Windows. We're going to map out exactly how this incredible piece of technology actually works behind the scenes.
To really wrap your head around this, just think about this massive number for a second. Over 1 billion. That literally means more than 1 in 8 people on Earth are connected by computers running Windows right now. I mean, from the laptop sitting on your desk to these massive, sprawling enterprise servers, it is the absolute foundation of modern computing.
All right, so here is our blueprint for today. We'll be going over the anatomy of the OS, the startup sequence, managing files and performance, defending the core, engineering the system, and finally, we'll look at the future of computing. Okay, let's jump right into Section 1, Anatomy of the OS, peeling back the layers. You know, when you really think about it, there's this wild contrast going on. Up on the surface, we have this friendly layer that bridges humans and system services. Basically, your everyday user applications and the Windows API. But underneath all of that, that's where we find the true powerhouse, the Windows kernel and hardware. This central engine interacts directly with the hardware abstraction layer, constantly routing these animated data streams straight to physical components like your CPU, your RAM, and your GPU. Just think about the sheer complexity of that digital kernel core for a second. It's kind of like an ultra-fast air traffic controller. It is simultaneously managing your memory space, scheduling threads, and firing off lightning-fast instructions to the file and security managers. From handling real-time interrupts to juggling virtual memory, this core is constantly working overtime to keep your machine incredibly responsive.
Moving right along to Section 2, the startup sequence, from power to productivity.
Okay, so in the time it takes you to take a single sip of coffee, we're talking literally 4 seconds, an unbelievable cascade of events happens. Right at 0 seconds, power hits the BIOS or UEFI. Just a half second later, the boot manager steps in. Boom, at 1 second, that complex kernel we just talked about starts initializing. At 1.5 seconds, device drivers wake up your hardware. By 3 seconds, you're already at the login screen, and at exactly 4 seconds, your desktop is ready to go. It's an absolute masterclass in efficiency, and honestly, you probably interact with it every single day without even noticing.
So once we're booted up, we hit Section 3, Managing Files and Performance, the invisible engine.
Behind every single saved document or photo, the NTFS file system is tirelessly working away like some obsessive librarian. It doesn't just hold your data, it's actively managing file allocation, enforcing strict permissions so only authorized users get access, and meticulously mapping out physical disk sectors. It executes these super rapid SSD read and write operations, seamlessly handles data encryption, and even sets up the whole framework for data recovery just in case things go sideways. Now, to prevent annoying crashes, Windows has to dynamically juggle resources in real time. We're talking about a perfectly optimal distribution between CPU usage, RAM allocation, and GPU rendering, all while handling background multithreading, task scheduling, and caching. It's this constant, completely invisible balancing act happening every millisecond to give you a smooth, crash-free experience. Which brings us to Section 4, Defending the Core, Security and Protection. Obviously, all of those active data streams need serious protection from modern cyber attacks, right? So Windows relies on a multi-layered defense strategy. Think of it like a giant digital fortress. You've got Secure Boot guarding the front gate during startup to make sure absolutely no malicious code runs. Then, you have BitLocker encryption locking down your data vault, while Windows Defender Antivirus is actively patrolling for external threats right alongside the firewall. Combine all that with constant Windows updates and super strict credential protection, and, well, you've got yourself an impenetrable layer defending the core system.
Let's shift gears a bit for Section 5, Engineering the System, the human element.
So this whole ecosystem, it's not built on just one language. It is a massive, sprawling technological stack. Engineers use C, C++, and assembly to build the hyper-fast engine block, the stuff interacting directly with the Win32 API and the Windows driver kit. But then, on the flip side, they use the .NET framework and DirectX to create all the rich applications and flashy graphics we actually see, managing the whole entire shebang using PowerShell and the Windows terminal. And to actually coordinate this level of global chaos, professional engineers rely on a highly orchestrated pipeline. Tools like Visual Studio, GitHub, and Azure DevOps make round-the-clock collaboration possible. This allows for continuous integration, incredibly strict quality assurance, automated testing, and increasingly, AI-assisted development. Actually, AI is catching bugs and writing better code before the update ever even reaches your computer.
I mean, when you realize it takes literally millions of lines of code to bring this operating system to life, it really grounds all these high-tech, abstract specs in sheer human ingenuity. It's teamwork on an unprecedented global scale, completely transforming raw computer logic into the seamless interface that we rely on every single day. Finally, let's zoom out for Section 6, the future of computing. What comes next?
Looking ahead, tomorrow's operating system is going to evolve into a vastly different environment. We are looking at really deep integration with intelligent AI assistants, systems that actually anticipate your needs before you even click a mouse. Windows will heavily leverage cloud and edge computing concepts to bring massive, mainframe-level processing power right to your local device. And honestly, there is even preparation underway right now for the completely paradigm-shifting potential of quantum computing.
As our hardware continues to transcend traditional limits, I want to leave you with this thought to chew on. How will AI, quantum, and edge computing fundamentally change what an operating system even is? How will these wild new technologies completely redefine our everyday relationship with computers? It is an absolutely thrilling frontier. Thank you so much for joining me on this explainer, and keep questioning the technology that powers our world.